So hello guys, this is Aditya Anand and here we are with the 13th question, that is find the sum of a series, such kind of a series that is shown here, which is followed up to n number of terms. So finding the sum is not a difficult thing, but to generate such kind of numbers up to n terms, like for the first term it is 1, for the second term it is 1, followed by 1. So for the second term there are 2 ones, for the third term there are 3 ones, and for the nth term there will be n number of ones. Okay, so generating these numbers is a challenge here, the main challenge. Then we can easily find out the sum. So first what we need is the value of n, up to how many terms do we want. Okay, so n can be taken as input, enter the value of n, right? But whatever the value of n is given in the console, it will be of type string, but we want n to be of type integer, right? So what we can do is we can directly typecast it. See, this was a problem in the previous video where we have seen that we had to typecast later, right? We could not typecast here because we were giving, see, 2 space 24. There is a space here and it cannot be directly converted into integer, right? So that's why we were converting it into integer in the second step. Here we can directly convert it in this way, or we can write it this way as well, like n is assigned to int of, and both will work same, okay, for this case, but not for the above case because there is a space here. Okay, so we have got the value of n, right? Now once we have got the value of n, how can we generate such series? Okay, so let us consider each term like this or this or this or ahead, right? Let us consider each term as num, as a variable num, which is initially empty. Okay, so for, we need to write a for loop for I in range n plus 1, right? Because we have to go up to n terms, not less than n terms. So n plus 1, and what we will do is we'll do num is equal to num. See, we have to add first, num is an empty string, we have to add a 1 here. So what we can do is plus 1. This is how string concatenation is done. Num is assigned to num plus 1. So empty string plus 1 will result in a string 1. Okay, then what we can do is for the next iteration, the value of num will be this thing, right? And we want to append another 1. So if we write this, it will work fine. Don't think that the value of num was 1 and this is 1, so it will become 2. No, this is not an integer, this is a string. So 1 after a 1 becomes 11, and that is actually not 11, it is 1 1, 2 characters of a string. Okay, it is not integer at all. So let us just print num here and let's see what is the output. Run. Suppose we are saying n is equal to 5. See, we got our string, right? And there is a problem. We're getting our string up to 6, so we have to write 1 here because we are taking it from 1 to n plus 1, or we can directly write n here. There is no issue with it. Okay, so we don't want up to 6, we want it up to 5. From 0 to 4 it will keep adding 1 by 1. Okay, so let me run this again and see whether we're getting the correct output or not. 1 2 3 and 4 and 5. Yes, so this was how we generated these strings. Now we just need to add them up, but before adding them up, we need, these are all strings. Okay, these are all strings, none of them are integers, so we need to typecast it into integer. Okay, so we need to keep a value sum, which is assigned to 0, as we used to do it, right? So, sum is for addition, and we cannot keep sum, I guess. Let's keep result result. Sum is a keyword. So result is assigned to 0. Why 0? Because the additive identity is 0. If it was and we are doing sum, if we were doing multiplication, then the multiplicative identity will be 1 and we would have used 1 here. Okay, so what we can do is, first we'll use, see, result is assigned to result plus the integer value of num, not the string. This num is holding string right now. These are all strings. Okay, so we want them to be typecasted to integer, and we want them to add up. So, and I also want to print num here because it will be better to view the results. Okay, now I want to print result, right? 5. So this is our final result, which is correct. You can verify by adding them up. Okay, and let me just run one more time. Let's say 3, sorry, 3, yes. So it will be 1 1 1 and 1 1 1. This will add up to 123, which is correct. Okay, we can verify this. Yes, so this is one way of solving this, and it is easier in Python because there is a plus operator which is used for string concatenation, but there can be many other ways to do it. Okay, we will just, since we have time, so we'll just explore one more method to do it. It will be a little bit complex, and such methods are not encouraged in Python, but as of programming, if just for a programming flavor, this method is also good. So let's try the second method. So we want the input there also, so we'll just copy these lines. This is the second method. Okay, and we want CLT result is assigned to 0, so we will keep this as it is. And what we will do is, we will generate a number, not a string. Okay, we will generate a number is assigned to 0. And see, again we'll use a for loop for I in range of I plus 1. Okay, see, this I goes from 0 to less than n, right? 0 to less than n. So we have to keep this j. Yes, so we want the second variable j to loop from 0 to I plus 1, such that what we can do is, see, the number was initially 0, so if we want to make it 1, what we can do is, number is equal to number plus 1 into 10 to the power 0, which is 1. So 1 into 1 becomes 1, and it is added to 0, so number becomes 0 for the first iteration. What if there are multiple such iterations? Like if we want to go for the second term, how will we do it? See, second term, when we enter the second term, again the value of num becomes 0, right? And what we do is, num is assigned to num plus I into 10 to the power we write this way, right? 10 to the power of j. So what we get here, see, for the second term, number will be 0 initially, and will enter this loop. Okay, and it will go up to, for the second term, the value of I is 1, right? So 1 plus 1, 2, less than 2, it will go up to less than 2. So the value of j will be 0 and 1. Okay, it is less than 2, so the value of j will be 0 and 1. So what we'll do is, initially the value of num is 0, it will be copied here, 0 plus I, not I, this will be 1. Okay, not I, because we are dealing with ones, right? So this will be 1 into 10 to the power of 0, hence the number will become 1 for the first time. And again the loop will run when the value of j is 1. So 1 into 10 to the power 1, that is 10. So 10, earlier num was 1, so 10 plus 1 becomes 11, and that's what we are doing here. For the third term, if uh, if we are calculating it for the third term, then the value of I will be 2 here, right? 0 1 2, third term is 2. So 2 plus 1 3, we have to go up to less than 3. Okay, so j ranges from 0 to less than 3. So for the two terms it will run and it will become 11. For the third term it will go up to 2, so 10 to the power 2, 100 plus 11, 111. So this is how it works. Now what we do here is result is assigned to result plus num. Now if we do a print of result, we'll get the same output. So let's do 5. See, we're getting this value. Let me run this again and let me try for 3 as we have done here, 3, and we are getting the same value. So these are some of the ways in which we can solve such kind of series. These so you can try other series like 9999. In place of 1 you can keep 9, and you can go up to n number of terms, or you can try some different kind of series. And if you're not able to solve, kindly comment down below. I'll be happy to help you guys. So this was it for today. I hope you enjoyed the video. If you like the video, hit the like and the subscribe button. Also share it with your friends. So thanks for watching. Have a great day ahead.